Welcome to 5.3 homework, question 11. Now this question asks us to find two things. We need to find the inverse of this equation and then graph the function and its inverse. So let's focus on finding the inverse first. So we're going to flip the x's and y's like that. And then we need to solve for y. Now this one is going to get a little weird, so let's go step by step. We're going to get rid of that plus 2 first by minusing 2 because we're going to think of PEMDAS backwards, or working farthest away from y and working our way closer, and that was an adding, so we do the opposite to get rid of it. And now we're left with this. Now here's the weird step. I do not like variables in the denominator, like ever. So I want to get that variable out of the denominator first by multiplying it. But then I have to do it to both sides. And now that variable isn't in the denominator anymore. And I've got this. Now remember, we're solving for y. So then the next step I can do is divide by this whole x minus 2 right there. And now they've kind of flipped places where my y's over on the left and now my x is in the denominator, which is what I wanted. It makes solving for y a lot easier. So now to solve for y, I'm going to minus 3 to both sides, and I've got negative y equals 4 over x minus 2 minus 3. And then here to get rid of this negative 1, I could divide by negative 1 or I could multiply by negative 1, either way. So I'm going to multiply and distribute that to make it look a little nicer. So I've got negative 4 over x minus 2 plus 3. So there's my inverse equation. Now I need to graph it. Now remember, we learned that the easiest way to graph these things is to plug some numbers into a t-table and then flip them. So that's what I'm going to do. I'm just going to pick some x values. So the ones I'm going to pick 0, 1, 2, 3, 4, 5, 6. I just pick those out of my head. And I'm going to plug all of those into my original equation. Now, easiest way to do that, just type it all into your calculator. But to save some time, I'm just going to give them to you all of what they would be. So this would be, we're going to have some decimals here, and that's okay. This one's very interesting. If you type this one into your calculator, it's going to give you an error. That's because it's undefined or an asymptote. So at 3, we're going to draw a dotted line asymptote. 4, and then that one gives you a negative 2, that one gives you a 0, and a 0.666. So now at this point, I'm going to graph these. So I've got 0, 3.333, 1, 4, 2, 6. That 3 is my undefined asymptote. And then I've got 4, negative 2, 5, 0, 6, 0.66. So you should recognize this is looking kind of similar to those rational functions graphs we did in chapter 4. So it's going to look something like that. So let me, while you're copying that down, I'm going to go through and color code all of these. Okay. Now, for the inverse, remember we just take these points on this table and we flip them. So now the y column now goes on the left, and the x column now goes on the right. And now let's graph these points. So I've got 3.333, 0, 4, 1, 6, comma 2. 3 is undefined, but now it's a y value that's undefined, not an x value, so it's going to go that way. And then I've got negative 2, comma 4, 0, comma 5, and 0.66, comma 6. So now we've got something like this. And remember, the whole point of this graphing thing is that I can draw this diagonal y equals x line. And I can see that if I take this red graph and I flip it across that diagonal line, I get the green graph. So if I take this red graph, flip it across, I get that green graph. That's the inverse graph pattern. They're always reflected across that y equals x diagonal line. And that's number 11.